Implement trie, a prefix tree. A trie, pronounced as trie, or prefix tree, is a tree data structure used to efficiently store and retrieve keys in a dataset of strings. There are various applications of this data structure, such as autocomplete and spell checker. Oh, really? Implement the trie class. Trie initializes the trie object. Void. Oh, okay, then I gotta delete this then. Void insert string word inserts the string word into the trie. Boolean search string word returns true if the string word is in the trie was inserted before and false otherwise. Starts with return true if there's a previously inserted string word that has the prefix and false otherwise. Okay, so I'm gonna start off with the default class solution. Or maybe it was called class trie. Maybe, I don't know. First we need an initializer. Okay. I don't know what the initializer needs, but we also need an insert. Remember, we're inside a class, so we always need to start with self. In Python, it returns nothing, I believe, but it takes in a word of string type. Alright, and then should I just write like, is that how it's done in Python? I don't know. We do want a boolean. And this one is called search. We want to begin with self and a word with string. Cool. And then we also want a boolean starts with and a prefix. We need self first and then prefix string. Okay. Let me try resetting this. Yeah, it was class trie, nice. Def initializer, def insert. Okay, none. Yeah, that's the way to do it. Self word string, self word string, self prefix string. Awesome. I'll delete this example down there. I think I know how to use this class. Maybe I'm wrong. And then we'll use the one I kind of created here to see if it works. So I don't know anything about tries. This is my first time trying it out. Pun intended. Yeah, it was just the first question in Nico 50 regarding this topic. I thought I'd give it a shot since I've never tried it before. In terms of initializing this tree, is it still the same idea of having like every node has like a left and right parent, or is this not a binary tree anymore? I don't know. I was gonna watch the NeetCode video that explains this concept, but I thought I'd just give this problem a try. I keep on saying try. I guess we can take a look at the example. Try, insert, search. Okay, so this is the commands. So we have try, it's empty right now, insert apple. Search for apple, true. Search for app, false. Starts with app, true. Insert app. Search for app, true. And then what? It starts with. So try, new try. Try that insert apple. Try that search for apple. I see concerns down there. I'm just gonna scroll up so I can hide that. How do you? So I can insert the word itself into the tree. Do I do that in a particular order? I don't know. there's no mention of whether this has to be a binary tree or not. So even like yeah, I I don't know whether I need a left or right children. Do I need children's like an array? How do I even implement this? Well, search is like, okay, we go through all the different elements, like brute force. We go through all the elements in the tree, which is O of n being the number of elements in the tree. Can we use log? Maybe if we sort it by the, I don't know, the kind of the order, like the A is kind of, you know what I mean, like alphabetically sorting it is what I'm trying to get at. Just an idea. Constraints out there. I should probably ask those questions. And then this starts with, I mean, I can think of the root. Like, is there any time complexity constraints mentioned here? I don't see anything. I didn't look at the constraints down there. Let me try and do that too. Yeah, but I have no idea how to implement the starts with. If like me, I can look through all the elements again in the tree, and then just kind of do a check. I feel like that's not. There's probably a purpose to try that I'm not able to see. That prevents me from. It prevents me from facing a time complexity of O of n. Okay, let me do the constraints now. So how many elements can be in this trie? Right? Can it be empty? Does it always need to have one element? How big can it be? Insert. What are the constraints on the word? What like elements can it contain? Can it just be alphabetical? Can there be numerics? Can there be symbols? Same thing for that word. Prefix as well. Can it be empty? I don't know. Just a question. This can be true and false. This can be true and false. The prefix doesn't necessarily have to exist in the tree. The word, can you have duplicate words? I don't know what happens then. Just a question. Yeah, let's see what the constraints are. Alright, so word.line, prefix.line, it has to be at least one, it can't be empty. It can be up to 2,000. And then word and prefix consist only of lowercase English letters. Okay, nice. At most 3 times 10 to the power of 4 calls in total will be made to insert search and starts with. Quite a bit of calls. Alright, so again, what I talked about the brute force method, that's the way I'm thinking of doing it. I don't know if there's a special, like, if there's something else I should know about tries that would help me in this question. Oh wait, hold on. Wikipedia. Operations. Searching. Insertion. Deletion. Let's read the beginning. Specialized search tree data structure. Unlike a binary search tree, nodes in a trie do not store their associated keys. Instead, each node's position within the trie determines its associated key, with the connections between nodes defined by individual characters rather than the entire key. Oh, what does that mean? Let's see. A trie for keys A to T, TED, English words. Yeah, okay, so there's not only 2 children, necessarily. What? Oh, I'm so confused. What in the world? Tries are particularly effective. Okay, we already know that. Every child node shares a common prefix. Oh, T, 2, T, T, 10, 10, A, I, N, N. Okay, so we need to keep it in prefix kind of order. Hmm. Hmm. Oh, sorry, I was silently reading. I think it was just this part that I didn't really get. Like, is it T A? Are these the? No, these are the values. Then there's children. What is the T A? Like the values on the edges. What did they? Do they signify? I guess it's like it's on. Uh, like it's the letter that you're adding to the node before, right? T and then there's O makes T O. T E and A makes T, like T E A. Hmm. I mean, here it gives us the find kind of method. What's the time complexity for this, out of curiosity? Takes O of m time, where m is the size of the string parameter key. Oh. I guess I'm kind of cheating right now, aren't I? Searching for a value in a trie is guided by the characters in the search string key, as each node in the trie contains a corresponding link to each possible character in the given string. Thus, following the string within the trie yields the associated value for the given string key. A null link during the search indicates the inexistence of the key. Kind of makes sense. Oh, what in the world? I'm like craving NeetCode's video right now. let me do that. Let me watch the video just to get an idea and see if I can come back to this and tackle it properly.